Hello, Algebros. We are going to be sketching graphs given some characteristics, and if the graph is not possible, explain why. So you're given a different set of characteristics on each of these, so there's no way that I could go over all of the possible things that you're going to run into. That's the hard thing with math, is that you just have to recognize patterns versus seeing an example of everything. So if it has a degree of 5, then we have 4 turning points. Starts in quadrant 2, so if you need a reminder of the quadrants, this is quadrant 1, quadrant 2, quadrant 3, oh, that's 4, sorry. Quadrant 3 and quadrant 4. So it starts in quadrant 2 and ends in quadrant 4, has a relative maximum at an x value of 3. So somewhere along here, and a relative minimum at an x value of -3. So somewhere along there. All right, so we don't have exact x values. We don't have necessarily the x-intercepts or anything like that. So we just need to start our graph in the second quadrant with a relative maximum at +3 and a relative minimum at -3. So you can dip below, you can come up, or you can make it go through. That doesn't tell us if we have any multiplicities either. So the possibilities are almost endless. There we go. All right, so my relative minimum is at a -3 and my relative maximum is at a +3. I started in quadrant 2, I ended in quadrant 4. Oh, 4 turning points, sorry. I forgot about that little part. Okay, so 1, 2, 3, 4. There we go. So again, they don't give us any special y-intercepts or anything like that, so you can you have some liberty to move it around as much as you want, as long as your relative maximum is at an x value of 3 and your relative minimum is at an x value of -3. You start in 2 and you end in 4, and you have 4 turning points. All right, let's look at number 5. It's an even degree, so that means it's going to look like this or like this. The a value is positive, so this is the one that it'll look like. It has 6 x-intercepts, that's a lot. It has an absolute maximum of y equals 1. Okay. So if it has an absolute maximum, that means it's going to need some sort of a hilltop at some point. But because of the positive a value, it tells us that our graph goes up. Therefore, there is no absolute maximum for a graph like this, because it's going to continue to go up forever and ever, and it's never going to tap out at the top anywhere. So this graph is not plausible because you can't have an even degree with a positive a value and have an absolute maximum. So some of these you can't draw, some of them you can draw. So you just have to kind of work with the characteristics. If it's possible, draw it. If it's not possible, tell me why it's not possible. So I did 1 and 5 for you. So you have 2, 3, 4, and 6. Happy mathing.